Workers' comp. Can't give out the final.
So are we going to start taking the derivative of that or no? Since we don't.
I just want to know the Maclaurin series for
That's
this.
1 over something.
This is 1 over something.
One over sine.
So we don't have a Maclaurin series right now for cosecant. We have a Maclaurin series for sine, don't we?
Sine or cosecant.
So isn't this just 1 over sine x? And isn't that just 1 divided by the infinite series? We've done this already. So 1 over 2n plus 1 factorial x to the 2n plus 1. Isn't that what that is? I should probably extend this division bar. Maybe put the 1 here instead. That's what that is, right? Now in the previous problem, we took e to the x and multiplied it times sine. And the question was, hey, can we multiply 2 power series together? And the answer was yes. It's a little tedious, but yes, we can, right? This question is saying, can you divide a power series into a number?
I don't know.
Of course you can.
Yes, because we're doing it right now.
It's called long division,
Oh,
right?
yeah.
Long division.
Very.
So this is equal to 1 over. All right, let's write out the series for sine. We've done this several times now. So x minus 1 over 3 factorial. X to the third. Okay, so y'all know where I am? 5 over 5 factorial x to the 5th plus dot, 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 dot. Right? That's what it is.
Yes.
Pay close attention to this. I'm going to show you something after this, and I think you're going to laugh. No, I think you're going to find it, hopefully, pretty humorous. All right. Long division. How do we do long division? We put the stuff that we're dividing in on the outside, x minus 1 over 3 factorial x to the third plus 1 over 5 factorial x to the 5th plus dot, dot, dot. And on the inside, we put 1, right? And now you have to ask yourself the question. What do you multiply x by to get 1? X to the negative 1. We used to say stop, right? We used to always say, hey, look, if the power of x out here is bigger than this, then you stop the long division, don't you?
Over everything.
Yeah, and you would write 1 over the remainder, which is this. So that doesn't help us, right? But we can use x to the negative 1, or I'm gonna write it as 1 over x, which is the same thing, isn't it? 1 over x, if I multiply 1 over x times x, I get 1. The question is, what happens when you multiply 1 over x times the rest of them? So 1 over x times x, that gives me 1. You all know what I'm doing here? This is the way we do division. Then you do 1 over x times this. All that does is changes that power to a 2. Now, I'm going to leave some space here, because I might later on have some x's appear. So I'm going to put an x squared column here, and I'm going to have minus 1 over 3 factorial x squared. Y'all okay with that?
Yes.
These are all zeros up here. Next one. X to the 4th, I better leave some space. It'll be positive. 1 over 5 factorial x to the 4th. And we could keep going, right? But I'm going to stop there. Good. Now what do you do with long division?
Now you add them. We're subtracting.
You subtract the rows, right? So you change the signs on everything. This is going to become minus, this is going to become plus, and this one's going to become a minus. And then you add straight down, don't you? Yeah. So if I add down, I get 0. Add straight down here, I get 1 over 3 factorial x squared. Add down here, I get minus 1 over 5 factorial x to the 4th. Are y'all still with me?
Yes.
What do you have to multiply x by to get 1 over 3 factorial x squared?
1 over 3 factorial x.
So plus 1 over 3 factorial x. Agreed? If I multiply this times this first one, I get this one? Yeah? Okay, so let's do it. That times that, I get 1 over 3 factorial x squared. Wonderful. And then I have to multiply this times this. So what power is it going to be?
4.
To the 4th, so it's going to go in this column, right? But what's the number in front going to be? It's going to be minus, what, 1 over 3 factorial times 3 factorial again? X to the 4th. Do you see how this is starting to look pretty bad? Question, yes.
Is it the same thing as 3 factorial to say, like, you know, that
This squared?
yeah.
As long as you write it like this. Yep, it is. Now, I didn't go any further, did I? I didn't go any further. So that we'll stop there. Now you come through and you subtract the row, right? So this becomes minus, this becomes plus. The first ones are gone, right? And then this is what remains, right?
Yeah.
Those two added together. Nice. Okay, so I'm just going to do this. It's whatever this is plus whatever this is. They both have an x to the 4th. Right? Isn't just the coefficient of this one added to the coefficient of this one? They both have x to the 4th, so that's our common factor. Now, I could mechanically go through and figure out what this number is right now, couldn't I?
Yes.
Let's do that for that one, just for that one. What's 5 factorial? It's 5 factorial. 5 times 4 times 3 times 2 times 1. 120. So you get 1 over 120, right? Plus, and then 3 factorial 6. 6 times 6 is 36. So we need to add these two together. So someone can do that on their calculator for me.
I have a question.
Yes.
Why did you put all that up there above the division?
Huh?
7 over 360.
The thing you put parentheses up top.
Oh, yeah. I don't know why I put that there. Hold on. Hold on. Thank you. Thank you. Thank you. This was... Hold on. I messed one little thing up. Hold on. It's not little. It's big. This goes here, right? This goes here. We added these down. This is what we have.
Yeah.
And then you have to play this game again. What do you have to multiply x by to get this, right?
Yes.
And so what we'd multiply by is this, but not x to the 4th. X what? Nope. Cubed. Nathan, I'm glad you caught that. Thank you, sir. Right, when we add down, these come here, and then we have to play the game of turning this x into this. To get to the 4th power, we need a 3rd power, and then to get this coefficient, we need, well, that coefficient. So what is negative 120 over 130, plus 1 over 36?
7 divided by 360.
7 over 360? So this is really turning into 1 over x plus 1 over 6x. I need it again. 7 over
360.
360, x to the 3rd plus ... There's your power series expansion.
You wouldn't put like you just put ... instead of taking the whole remainder and put 1 over. ...
Yeah, no, because your remainder is infinite. Yeah, just leave it.
Okay.
I wonder if Wolfram Alpha will tell us the same thing.
That's pretty cool. No, as long as you give us that table, I think I might actually do all right on that.
All right, so what do we have here? What did I do? Cosecant x?
Yes.
If I just type it in, it should spit the power series out. There it is.
Do you think
What about for arc sine?
What about for arc sine?
Would it be like different than like, well, like how much different would it be for like the Maclaurin series?
The Maclaurin series?
The regular sine function, like, I don't know, I'm just
You would have different options. The question is, could we come up with the power series for arc sine, right? Let me see. Let's see if we can. If we have, I'm going to write y equals arc sine of x. right? Arcsine x, something like that. Now, I don't know the power series for arcsine, right? So if I were doing this, I might do this. This is just first instinct here. I know sine of y is x, right? I know the power series for sine, but I'm not going to be able to solve that for x. So, no. Well, we could start running your Maclaurin series. Derivatives, right? The Maclaurin series gives us our, when we run like the 0th derivative, right? Then the first, second,